Welcome to our podcast. I'm Rachel.
I'm Ryan.
And I'm Kate.
And this is CRISPR
treating
antibiotic resistance.
Please ignore that cheesy opening. Enjoy this podcast.
Okay, so today antibiotic resistance is becoming an increasingly big issue in the world.
We all know this is because everyone's misusing antibiotics and not using them until their date is up, and the threat of superbugs is becoming an increasingly big problem.
But there is a promising alternative because we can use CRISPR to fight off these bacteria. They'll not only kill the normal bacteria, but they'll kill the antibiotic-resistant form.
Dang, that's cool.
Okay, so for this new CRISPR to fight bacteria, I know that you would take it in a pill, and so the CRISPR system would be inside it, and in order to prevent the bacteriophages.
Phage?
Wait, hang on.
Bacteriophages.
Bacteriophages. Okay, so the bacteriophages wouldn't dissolve by the stomach acid because the pill has a bunch of probiotics around it. But how exactly would this work in the body to kill the bacteria?
So basically the CRISPR system uses this strand of guide RNA, which is pre-made within a lab, and it's specific to the bacteria we're fighting. And this guide RNA is inside a Cas9 enzyme. The guide RNA reads through and identifies a specific bacterial DNA sequence, and
the bacterial DNA will match with the guide RNA, and then once this Cas9 identifies the bacteria DNA, it will cut the bacteria DNA, so then, therefore, the bacteria will die.
Alright, that makes sense.
Mm-hmm.
And then this process will just basically keep on continuing until all the bacteria that match with the guide RNA are eliminated.
So no survivors.
Alrighty. So the only disadvantage of this, though, is while it seems like a pretty cool process, is that CRISPR needs to be specific to the genetic sequence of the bacteria that it's targeting. So we're not just going to have some overarching antibiotic.
At 2 minutes 24 seconds, Ryan screws up. What she meant to say was CRISPR but actually said antibiotic. Please enjoy the rest of the podcast.
It has to be very specific, and it's not an immediate treatment because of this.
Okay, but today, if you get strep throat, for example, you still have to do the swab test or get the tongue compressor or whatever it is on your tongue where you gag and it's really awkward, and then they give you the test results back in a few hours the next day. So essentially, it would probably be about the same time, right? Depending on how far the research has come by the time this is implemented.
Yeah, I think the only difference would be the broad spectrum antibiotics, but I mean, those can technically still be used with this system. But it is good. This does hold many advantages because it will only kill the specific bacteria that it needs to. It won't kill any of the probiotics and good bacteria in your body, which many antibiotics do kill.
It just wipes them all out. Okay, so I guess that's where the whole, it solves the problems with antibiotic resistance today in superbugs, because there's not going to be any bacteria that's left over with the mutation to fight off CRISPR, because CRISPR is going to kill it. So, evolution can't occur, the bacteria can't keep replicating, and there wouldn't be any more superbugs to worry about.
Mm-hmm. And so, along with those, we also know that the research for CRISPR is, while it's still ongoing, the majority of the research being done has showed great success, and we think that can further in the future.
This has been a successful chat, ladies.
Yeah.
Thank you for listening to our podcast.